Welcome to the next topic, topic 9.2, where we're going to be working on our next part of the mole. For this lesson, you definitely need your periodic table yet again and that mole map resource. So please have those two things ready along with a calculator. So from yesterday, we talked about molar mass, but specifically how to find molar mass of one single element when we were talking about things that are counted with atoms. So we talked about magnesium and we talked about calcium, and we used the periodic table to find their molar mass. We're going to build on that today, and we're going to talk about how in the world do you find a molar mass of something that is a compound. And so there's some similarities with what we did yesterday, but obviously we have multiple elements because we're talking about a compound. So how I find molar mass of something that is in a compound is I take an inventory, kind of like we're balancing. So I list out what we have. So we have table salt, sodium chloride. So I have Na and I have Cl. The next thing I do is I look at how many I have of each. I have one sodium, I have one chlorine. What I need to know is what is the grand total of their molar mass of all of these elements combined. So what I do next is I use my periodic table to find the individual molar masses of these two elements. So sodium, off to 2 decimal places, is 22.99. Chlorine to 2 decimal places is 35.45. We want the total, so you add these together. So essentially, we're just adding the mass of our sodium to the mass of our chlorine, and that is the molar mass of the compound. And so when we take a look at that, you get an answer of 58.44. This is molar mass. So just like yesterday, molar mass always has the same unit. This is how many grams are in 1 mole of this material. In the next compound, we have calcium nitrate. So listing out our elements, we have 3. We have calcium, we have nitrogen, we have oxygen. We need to take an inventory on how many we have. We have 1 calcium, that 2 distributes in, we have 2 nitrogen, and that 2 distributes into the 3 on the oxygen, we have 6. We then look at the molar mass of each of these individual elements. So calcium, it looks like if you round that off, it's 40.08. Nitrogen, it rounds off to 14.01 because of rounding. And oxygen, because of the 0.999, we get 16. So then we just add these all up. So you can just type them into your calculator. So this is how I do it. Not that you really need to type the 1, but we're taking 1 times 40.08, add that to 2 times 14.01, add that to our 6 oxygen that are at 16, and the molar mass of the substance is 164. Because these are to 2 decimal places and we're adding, we're going to put 10 gram per mole. So if you want to take a minute and pause the video, see if you can work out the molar mass of aluminum sulfate. But before you do that, there is a mistype on my side, and I'm missing that 3 there. All right, so if you took my advice and paused the video, this is what you should have got. So you have aluminum with 2, sulfur with 3, oxygen with 4. Not 4, 12, because we have 4 times the 3. We just used oxygen's molar mass at 16. And utilizing your periodic table, aluminum, you should have found that it's 26.98. And sulfur is 32.07. Again, add them all up. If you did so correctly, I got an answer of 342.17 grams per mole. So again, we worked with molar mass, doing conversions with it, but they were for things that were just elements. We're going to start looking at that, how you'd work through that if you're talking about something that's a compound. So in the very first example, to review on concepts by building them up just a little bit from yesterday, this first question asks, how many moles? So that's what I'm solving for. And my given is 127 grams. And so it also tells me that I'm working with barium chloride. So again, you have your mole map. I have a given that's mass because of grams, and it wants to know moles. So in order to get from that town to this part of the town, or using, again, the pathways, we need to know its molar mass. It's a compound. So we have to do like what we just did. We have barium, we have chlorine. We have 1 barium, we have 2 chlorines. Again, you'll utilize your periodic table to identify their masses and get a total. So looking at how I worked it out, barium, it looks like it's 137.33. And chlorine is 35.45. Again, you multiply and then add the 2 up. The grand total molar mass here is 208.23 grams per mole. All right, so now we have molar mass. We know what we have as a given. We know what we're solving for. We can then start setting up the problem. Taking our given of 127, that's 3 sig figs. My answer can have 3. So my given unit is grams, therefore I need to divide by grams. This part of the conversion will go in the denominator, so 208.23. The other half of the conversion, that per mole, here's my per, 1 mole will go in the top, and I'm also going to include that this is BaCl2. Finally, to solve, we're just dividing it out, so taking 127, you're going to divide that out by the 208.23. You're going to keep that to 3 significant figures. So when I did that, I got a final answer of 0.610. And that, again, with adding that 0, it keeps that third sig fig. So we have moles, and this is of barium chloride. So in the second example, it asks how many formula units. So this is something we haven't seen yet, because we didn't work with compounds yesterday. Looking at your mole map, and you may want to jot this down, is again, there are 3 units that we use to include in a representative particle. So atoms, we use that for anything that is an element. So calcium, lithium, fluorine, sulfur. Molecules are anything that is Hoffenkleiber or something held together with covalent bonds. So carbon dioxide, nitrogen monoxide, sulfur hexafluoride, and then things, the Hoffenkleibers, so hydrogen, oxygen, iodine, bromine, so H2, Br2, those are all molecules. So that leaves us with formula units. Formula units are for representative particles that are held together with an ionic bond. Again, like I said, chemistry, nothing ever goes away. When you think you're done and you'll never see it again, it comes back with a vengeance. And so formula units are things that are held together again with an ionic bond, meaning ions. So a metal and a nonmetal. So the reason why they ask for formula units of barium chloride is we have a metal with a nonmetal. So we start with our given, 1.27 moles of this BaCl2. We need to have a plan on how are we going to get to this destination. Our destination being formula units. Our given is moles. We're going to a representative particle. That means we need to use Avogadro's constant to get there. So again, when you're setting this up, my given is moles. Therefore, the denominator is 1 mole. My numerator is Avogadro's constant. And formula units have a classy abbreviation of FU. Multiplying to solve, and I'm going to get this calculator out of my way. I really want to use this one. So again, we're going to take 1.27 times 6.022. I'm using that EE function by doing second comma, 23. This has 3 sig figs. I can keep 3 in my answer, so I can keep 7.6, and that 4 is going to round up to a 5. I see that E 23rd, so that means times 10 to the 23rd. Moles have canceled here, so I'm left with formula units of this barium chloride. And that is my final answer for the second review example. So the only thing different from yesterday to today is I've introduced the idea that we can work with compounds. So molar mass, again, not anything new. Avogadro's constant, not anything new. All one-step conversions. Okay. However, one-step conversions aren't always the case. Depending on what you're trying to achieve and what kind of chemistry you're working with, problems may take more than one step. when you take a look at this problem, it asks how many molecules, so this is what I'm solving for, are there in 125 grams of sugar? Common table sugar has a formula of C12H22O11. So when you take a look at your roadmap, it wants to know a representative particle. It wants to know molecules. The given unit in this problem was grams. There is no direct conversion between these two. So you always, and we'll kind of work through all of these by the time we get done with this unit, is you have to convert something to mole. Again, it gives us a quantity that we can compare things to go from one thing to another. And so what we need is we are going to have a two-step conversion that's going to lead us from mass to mole. And then we can go from moles out to a representative particle. Therefore, 2 steps. So what I can see is the first leg of my journey on my mole map is going to involve molar mass. So that's the first thing I'm going to do, is determine the molar mass of the sugar. And so, like I said with the examples before, is we need to take an inventory similar to balancing. So we have carbon, there are 12 of them. Hydrogen, we have 22. Oxygen, we have 11. To 2 decimal places, carbon rounds off nice and easy to 12.01. Hydrogen, all through college, my professors, we always just used 1. If you use, it pretty much I would just go with using 1. It makes things easier if you're on the same wavelength as mine, so answer keys and your answers match up to make it more easier on your end than anything else. And then oxygen rounds off to 16. So again, you multiply these 3, add all 3 up. When you do that, you get a grand total of 342.12. It's molar mass, so grams per mole. We have enough information to start setting up. Take your given. We have 125.0 grams of the C12H22O11. When we set this up, my given unit is grams. The only thing I can use to get rid of grams is its molar mass. So that 342.12 grams is going to be the denominator. The numerator is going to be the 1 mole. What I see happen is my grams eliminates. However, the problem did not ask for moles. It asked for molecules. That is how I know that I'm not done. Following my roadmap here, I have converted from here to here. That's how I know I need 2 steps, because I'm not at my desired unit. It wants molecules or MQs. So to get from here to here, we've done this leg of our journey. We now need to complete this leg using Avogadro's constant to then solve for molecules. Plugging that in, it's nice to cancel units out to keep track of things. So I have 1 mole in the numerator. Therefore, I need to divide by moles in order for those to cancel. And that means Avogadro's constant is going to be my numerator. You have 2 options for how you can kind of work these out. You can multiply everything across the top and then divide it out, or you can do it step by step. I'm going to do it by consolidating my numerator and then dividing it out. So I'm going to take 125. I don't need to multiply it by 1, but I do need to multiply it by the 6.022 E23. I'm going to go ahead and hit enter. Divide 342.12. My given unit has 4 sig figs, or my given measurement, not unit. And so that means I can keep 4 in my answer. So I keep the 2.200. The 2 does not round that out, so I just say 2.200. My final unit then is MQs, and actually I'm missing something. Reading all the way to the end, and I just about did the same thing that I was going to tell you not to do. Make sure that you put in your scientific notation. So this is times 10 to the 23rd. Now let's talk about units. So this is MQs of the C12H22O11, or sugar. Okay. Another practice problem. It asks, what is the mass of sulfur or 6.55 times 10 to the 23rd molecules of sulfur dioxide, which has a formula of SO2. So let's take a look at what we are given. We're given molecules. It wants to know mass. As soon as you see mass, whether it's in your given or you see mass is what you're solving for, as soon as you see the word mass or anything about grams, you know you are going to need a molar mass. Our compound is sulfur dioxide. So we have S and O. 1 sulfur, 2 oxygen. Oxygen I know is 16, and sulfur is 32.07. Multiplying and adding everything up, you get an answer of 64.07 grams per mole. Let's take a look at what our given is. It's that 6.55 times 10 to the 23rd MQs of SO2. Look at your mole map if you're not sure where to go. We are at a representative particle because we're talking about molecules. It wants to know the mass. Again, there is no direct relationship that connects these two. We then use Avogadro's constant first in our first step of the conversion. Avogadro's constant will go in the bottom to cancel those units. And the top is to 1 mole. I can cancel MQs. I can see that I'm now at moles. Again, the problem wants us to get to mass. So I can see to get from moles to mass, you need the molar mass, which we've done that work. Setting that portion up, I can see that I have 1 mole here. That means 1 mole will go in the bottom, and the mass of 64.07 grams will be the numerator of that conversion. I can also cancel out the mole. I can see that I have grams. I know grams measures mass. That's a good indication that I'm on the right track to get where I need to go. Again, for solving, I'm going to run this through by simplifying everything in the numerator. So I'm going to take 6.55 E23 times 64.07. Go ahead and hit enter. Divide 6.022 E23. My given here has 3 sig figs, so I can keep 3 sig figs here. So I get 69.6. That 8 rounds it up to get a grand total of 69.7. And this is grams of sulfur dioxide. So the last 2 problems on this note page are just additional practice working through what we've just done. I would highly recommend that you pause the video, try working these 2 out, also put it through your calculator, and see how things compare. So again, I hope you took my recommendation on trying to solve these on your own. The first thing you should have done was find a molar mass. Using 13 carbons at 12.01, 18 hydrogens at 1, and 2 oxygens at 16. The reason why you needed that is because your given is grams. The molar mass I calculated, it was 206.13 grams per mole. I would then take my given of 33 grams of the C13H18O2. I would then go ahead and, because I have grams, that means grams needs to go in the bottom. That more specifically should be the 206.13 grams, 1 mole in the bottom or in the top in the numerator. I can see it's asking for molecules. I know I'm not done because grams cancels. I'm left with moles, not molecules. I know how to get from moles to molecules using Avogadro's constant. Because 1 mole is in the numerator, 1 mole goes in the denominator of my new conversion factor, Avogadro's constant in the top. And I'm going to abbreviate that as MQs. Moles cancels, and I'm on my road to start solving. Take 33 times Avogadro's constant, hit enter, divide by the 206.13. When I take a look at answer for sig figs, this has 2 sig figs, so I'm only going to keep 9.6. E22, so times 10 to the 22nd MQs of ibuprofen, which is C13 H18O2. So hopefully that's what you got for example 3. And last but not least, example 4. It asks, what is the mass of 4.65 times 10 to the 24th molecules of water? So you can see right away that you have a given of molecules. So 4.65 times 10 to the 24th MQs. Water we know is H2O. The first thing you can do when you have MQs, because we were going to mass, is the only thing that you can use to get rid of MQs is Avogadro's constant. So 1 mole is to 6.022 times 10 to the 23rd. Okay, and those cancel. It wants mass. Moles does not measure mass. Grams does. So you need the molar mass of H2O, using that you have 2 hydrogens at 1 gram apiece. And oxygen, we have 1 at 16. Molar mass of water then is 18 grams per mole. When you use that as a conversion factor, the second step, 1 mole needs to go in the denominator to cancel, and the 18 across the top. Moles cancels, I'm at grams, which is mass. Solving this out, I take 4.65 E24 times 18. Enter, divide 6.022 E23. This has 3 sig figs, so 138. That 9 rounds it up. Your final answer is 139 grams of water. So again, one thing to look out for with this homework is you really need to probably get used to using your mole map for now. And you really have to look at what you have and where you're going, because we've done 3 things now. We've done conversions going from just moles to mass. We've done conversions going moles to representative particles. And now we've connected the 2. So you have 3 different style problems to only use 1 step from here and here. And then the third one uses 2 steps. So look at your given, look at what it's asking you to solve for to help decide what parts you need. If you have questions, need help, please let me know.